What are tuned mass dampers in skyscraper construction? Imagine standing on the ground and feeling the skyscraper sway gently in the wind or during an earthquake. How do engineers make sure that tall buildings stay stable and safe? Today, we're going to explore a fascinating device that helps achieve this: tuned mass dampers. These are special systems installed in very tall buildings to reduce the swaying caused by forces like wind or seismic activity. They are a key part of how modern skyscrapers have evolved to become taller and more slender. Tuned mass dampers are made up of a large heavy mass, often a steel or concrete block, connected to springs and dampers. This mass is positioned near the top of the building where sway is most noticeable. When the building moves, the damper moves out of phase with it. This means it moves in the opposite direction, creating forces that counteract the sway. Think of it like a swing. When you push it at just the right time, you can slow it down. The damper absorbs the energy from the building's vibrations, preventing excessive movement. The main goal of a tuned mass damper is to match its oscillation frequency to the building's natural sway frequency. When they are in sync, the damper absorbs the kinetic energy from vibrations and dissipates it as heat. This process reduces how much the building moves, making it more comfortable for occupants and safer for the structure. Without these devices, tall buildings would sway more, which could cause discomfort or even damage over time. One of the most famous examples of a tuned mass damper is in Taipei 101, a skyscraper in Taiwan that was completed in 2004. It features a 600-ton steel pendulum suspended near the top floors. This damper can reduce sway by up to 60%. It is visible to visitors and has become a symbol of engineering innovation. The damper helps the building withstand strong winds and earthquakes, which are common in that region. Tuned mass dampers are made from dense materials like steel, sometimes combined with concrete or lead to maximize effectiveness. They can be passive, meaning they only relying on the mass, springs, and dampers, or semi-active and active systems that adjust in real time. The choice depends on the building's size, location, and vibration characteristics. Installing these dampers near the top of skyscrapers is essential because sway is most noticeable there. These devices have played a big role in the societal and architectural evolution of skyscrapers. They allow architects to design taller, slimmer, and more flexible buildings without sacrificing safety or comfort. This innovation has helped push the limits of what is possible in urban construction. It also reflects how engineering solutions have adapted to meet the demands of growing cities and environmental forces. In practical terms, tuned mass dampers are carefully calibrated and installed during the building's construction process. They are tested to ensure they work effectively under different conditions. The cost of installing a tuned mass damper can range from a few million to over $10 million, depending on the size and complexity. Despite the expense, they are a vital part of modern skyscraper design, helping us build taller and more resilient structures for the future.